So hello everyone, I'm Dr. Shruti Pandey from University of Louisville. So in the last video, we have already discussed about the basic concepts of star and delta voltage and current. Now we are going to take a very basic example. So I have noted down the terms which we have derived from the previous video. So in case of star or Y connected system, line voltage is equal to line current is equal to phase current, and line voltage is equal to root 3 times phase voltage. Similarly, in case of delta, it's exactly the opposite. Line voltage is equal to phase voltage and line current is root 3 times phase current, and power of complete power of three phase load in terms of line voltage and current is this, be it star or be it delta. In both the cases, we derived that root 3 times VL IL cos theta is same in both the cases. Now we'll come to the question, what has been asked. So we'll keep on noting down that what all has been given in the question. So it says a three-phase star connected generator. So we can see that this is a star connected and it's a generator side is connected through power lines to a delta connected load. So this is load, right, which is delta connected, and this is source, this is generator source, which is star connected. So now what has been given in the question, each phase of the generator means this, each phase, there are three phases, each phase produces 277 volt, right? So that means at generator side, phase voltage is given 277 volt, and that means that all the three phase voltage is 277, 277 and 277, right? Now what else? The load consumes 180 kilowatt of power. Now they have not mentioned anywhere that it is single phase power. They are saying that entire load consumes 180 kilowatt of power with power factor 66% lagging. That means that P total is given, right? So P total, that means from the load side, total power is given 180 kilowatt. What else is given? Power factor. Power factor is cos theta, which is given 66%, or you can say 0.66, 66 by 100, which is 0.66. Now we will see what all we have to find. First, we need to find the line voltage, right? So in terms of voltage, what value is mentioned in the question? In terms of voltage, phase voltage is given and they are asking for line voltage, right? So we know this, that this is star, and in case of star connection, V line is equal to root 3 times phase. So V line has been asked. So that will be V line is equal to root 3 times V phase, that is under root 3 times 277. I think this will be 480 volt. So this is line voltage, right? So in terms of, you'll have to check that in terms of voltage, which one is given, this side voltage is given, and also see that the line things are common, right? Line things are common. So line voltage for the source side and line voltage for the load side will be same, because these three lines, they are common, right? So phases are different, because here phase is, in star connection, phase is always in terms of neutral. So phase values will be different, but line will be same in terms of when we are talking about both generator and load both. Okay, next what have they asked? The phase voltage of the load. Now they are talking about load, this side load. So phase voltage of the load. So we'll see that what is the phase voltage of the load. Phase voltage of the load is equal to V line, because the load is in delta connection, right? And there in delta, V line is equal to phase. So whatever will be the V line, that will be the value of V phase. And I told you that you can see that these three lines are common. So V line for the load will be equal to V line for the source. Okay, because lines are common. So this will also be 480 volt, right? Because the line voltage of generator side is 480 volt. Now what is the next? Next is the line current, right? Line current. So line current, here only voltage was given, here power is given, right? So we can calculate the value of line current from this term, because line is same, be it this side or this side. So C part is line current IL. Okay, so we have this power formula. So total power which was given 180 kilowatt is equal to, from this formula, under root 3 times VL. VL value is 480 volt. When we are, this is load side, right? So we'll take everything from load side, into IL. So that way IL will be equal to 180 kilowatt by under root 3 times 480, and this value, I think I have calculated it. Yeah, so this value is 328 ampere, right? So 328 ampere is the line current. Now whenever line current we have calculated from the load side, but we know that line values are same, be it voltage and current, in terms of generator and load both. So if somebody is going to ask the line current for generator side, we have calculated from the load perspective. If somebody is going to ask the line current for the generator, then this is same. Whatever current is coming from here, same is here. Whatever is coming from here, same is here. Here, same here. Okay. So now what is the next part? Phase current of the generator. Generator in star side. So star side we will see I line is equal to I phase. So D part is I line is equal to I phase, and they are asking for phase current. So no worries, line current of load is there. That same line current will be at the source side also, and in star connected, line and phase are equal. So that means I phase is equal to 328 ampere, right? Because this is source side. So I line for the source side is same as I line for the load side, because this is a common line. Okay. And as this is equal to I phase, so 328 will be the value of phase and line both. Okay, now next is the phase current of the load. Now they are asking for the phase current of the load. So I told you line parameters are same, but phase are not same. So E part is I phase current of the, is it asking for the, no, they are asking for the generator, not for the load. Okay, so they are asking for the generator. Did we already calculate? Sorry, the phase current of the load they are asking. Sorry, I'm sorry. So phase current for the load. So E part is I phase for the load. So we'll see load is in delta. In delta, IL is equal to root 3 times phase. So phase will be IL by under root 3. IL is 328 by under root 3, right? So I might have the value calculated. Yeah. So this comes out to be 189 ampere. So this is I phase of the load side. Okay, now what's the last thing? The power consumed by one phase of the load. Okay, so the total power is given in the question, 180 kilowatt. So total power means power consumed by all the three loads is given, right? So no worries. I mean, if all three phase power is given as 180 kilowatt and they are asking for power of single phase, it will be 180 kilowatt by 3. That will be 360 kilowatt. So this is single phase power. Okay, so one or two other thing which I will ask you in the quiz, and they are not asked in the question. So I'll tell you F part. If somebody is going to ask the impedance Z, you know this, right? What is given? You can see that, you can see that it is asked in the question. It's mentioned in the figure also. Z is given, right? Z is given. So definitely impedance is there. This is not purely resistive circuit. This can be seen with in two terms. We can see that impedance is there in the question. It's not only resistance. It has certain inductor or capacitor thing in it. How? We can also see that it says power factor 66% lagging. So if we'll come to the civil thing, right? So in case of inductor, current lags voltage, and in case of capacitor, this current leads. So if they are saying that it is lagging, that means inductor is also there in the circuit, right? So they are asking for Z value, and that too I'll ask that Z in one phase, right? So 3 Z's are there. 3 Z's are there. This is impedance for one phase, impedance for two phase, impedance for three phase. All three are same, but I'm asking only one Z value. If I'll ask total, then you will do 3 times Z. So if I want to know Z for single phase will be equal to voltage for single phase upon current for single phase, and what? The load values, right? Because Z is there in load. So what's the single phase load voltage here? It is 480, right? So 480 by what is the single phase current here? This is 189. Now comes a very important thing, whenever when I introduce rectangular system, that is Z is equal to R plus JX, I introduced a polar form also, which was that this Z can be represented as the magnitude Z and an angle Z, right? So this magnitude was nothing but R square plus X square, and what was this theta? Whatever it was, tan inverse X by R, or it can also be written as this theta was the angle between voltage and current, that is theta V minus theta I. If it is lagging, then the voltage angle is theta V and the current angle is theta I. Okay, so this theta is I'm going to write like this. I'm going to rewrite like this. So this will be, rather first I'll rub this. I wrote it down so that you don't have any confusion, but now this will be theta V upon theta I. So this Z is written in rectangular form, right? And whenever voltage is written in rectangular form, it is written like this. This is the voltage magnitude and this is the voltage angle. Whenever current is written in rectangular form, this is the magnitude and this is the current. Okay, so now I'll write it down again. It was 480, it was 189, and whenever rectangular form, polar form, this is all polar form, not rectangular. I'm so sorry for writing this as polar, right? So this is polar form, this is rectangular. So whenever I am dividing two polar forms, you know that the angles, they are subtracted. So it will be theta V minus theta I, and it is very clear that it says that it is 66% lagging, and lagging is always in terms of inductive load. So this theta V minus theta I is that this is a voltage waveform, this is a current waveform, right? And there is this angle theta, and this theta, this might be theta V, this might have an angle theta I, and this theta is theta V minus theta I. Okay, so this will be theta V minus theta I, and this theta is given in the question. Did you notice that this is just theta? Cos theta is given this, then we can easily find the value of theta. Cos inverse 0.66, which will be, I think, 48 degrees. 48 degrees, yeah, 48.7 degree, I think it will be. So we can solve this. Z single phase will be equal to 480 by 189 angle 48.7 degrees. If I have, yeah, so it will come out to be 2.54 angle 48.7 degree. Okay, so this is how, so this I'm going to give you in the question. So you need to remember that this Z, whenever there is something Z given, it has an R component into it, it has an X component into it. X can be either XL or it can be XC. It is XL or XC. You can know by this that if current is leading, then voltage, then it is XL, or lagging. When current is leading the voltage, then it is something XC. It will have a negative or positive Q as per that, or reactive power as per that. Okay, so whenever this kind of impedance will be asked, you need to write voltage upon theta T upon current upon theta V. So they are talking all about the load side, and load has that impedance or Z thing into it. So this voltage will also be of the load voltage, and this current will also be the load current. They are saying, they are talking the single phase one. So this will be load side phase voltage, this will be load side phase current. Okay, this was it. And yeah, that's I think this is sufficient. And if somebody is going to ever ask you this question, that how much is the power generated, like power consumed is already given in the question, that this load is consuming 180 kilowatt of power. So if somebody is going to ask you power generated, so that will also be 180 kilowatt, because power generated is equal to, power consumed. Right, so that's it. Practice this question well, and we are going to take the same question in the quiz tomorrow. Thank you.